Hi. In the context of this conversation, we're going to exemplify one type of analytical agent which is focused on the extraction of evidence from the literature. This is a particularly interesting use case as in many scientific endeavors, the dialogue with the literature, the evidence that's expressed in the literature, and this, of course, transcends scientific endeavors, but it's particularly important in scientific areas, is a fundamental part of the scientific process. So we're going to focus on how can we build an analytical agent that can extract this type of evidence in a controlled manner. The challenges of delivering this type of extraction, and we are framing here as a kind of systematic literature extraction task, is that we have a set of papers, for example, or scientific reports. And from these papers and scientific reports, we are interested on specific values and parameters, right? So we go from a set of papers, multiple pages, into a table, right, which structures this type of information. The challenges involved on that is first, when one is building an agent for doing literature review, one needs to understand the specific information needs from end users. So not all analytical agents focused on literature review are exactly doing the same task. We have specificities in terms of the score structure, specific terminologies, which can be quite specialized. And we need to perform this extraction in a quite controlled context, right? So we need to be safe that the extraction that was performed is clean enough, is not injecting hallucinations, is not injecting noise, right? So we need to have well-designed safety mechanisms to deliver this extraction. In the context that we are going to use as a case study, we are focusing on a problem in the context of cancer clinical trials management. When people are facing new treatments, in particular immunotherapies, which are experimental, they may face adverse events, right? So in the specific case, one type of adverse events called cytokine release syndrome in the context of immunotherapies, for example. And what we would like to do is, based on previous studies, we would like to see what are the parameter values and dimensions, essentially the types of cytokines, which are specific types of parameters which are interested, are mentioning at each paper. So the manual process to establish this and to extract this manually over 17 papers, as we estimated, and did actually in practice, was 40 hours. So it took 40 hours to manually build that table. And with an analytical agent, this can be reduced to, in this case, 7 minutes in this specific example. So the implementation of these types of agent infrastructures can represent a major order of magnitude efficiency gain into that extraction process. So this in itself justify the creation of these types of agents. So this is more or less a depiction of the problem that we have. So we have quite specialized papers involving the literature on adverse events, in particular CRS events in the context of immunotherapies. And then we are extracting on the right-hand side the presence or absence of these parameters as they are mentioned or not mentioned in those papers. So this is just to give a depiction of the types of extraction that we are looking at. Now, to build such an analytical agent, a naive approach is not the solution, right? So one cannot just upload these papers into a certain LLM infrastructure and then just expect that one would have control, sufficient control to have a clean extraction. As one can see in this diagram, the large language model, the LLM here, is one component out of many other components that need to be in place in order to deliver that controlled extraction, right? So, and essentially the shape of this workflow, it starts with robust extractors for the content that, in this case, all the files are PDF, right? So it starts with that PDF extractor. Within the PDF, some of the information may be expressed within the text, within the general discourse of the text. Other types of information may be expressed in the table. So we need to essentially separate the types of extraction that we have. Tables, we need then to represent the information that's in the tables in a way that the language model can interpret. That's what we're calling here the stable linearization component process. So we are, and this essentially means going from the structure of the table to a kind of a factual representation of these tables. Then this is done, we essentially extract elements which are only associated with relevant sections. We don't want to extract information from other sections, as this may involve different contexts that we are not interested in. And with all this base extraction, we can define a context window where we have all the factual knowledge that's required within the context of a specific paper, right? Based on that, we have a set of prompts which are engineered and tested in advance so that we know what we would like to extract, right? So this gives the overall intent of the extraction. And together with that, we have a component that allows us to dialogue with a thesaurus, which is specialized within the medical domain. In this case, this NCI thesaurus. So this is particularly important because of the specificity of the terminology. These specific parameters require that type of expansion as they can be expressed with different terminologies, different synonymic expressions, different types of acronyms. So we need to account for that vocabulary terminological specificity, right? And the point here is that we are not assuming that the language model has this rich representation internally. And that's an important engineering concept in the context of analytical agents. So what we're doing is expanding and not assuming any context, any specialized background knowledge within the agent, right? And by doing that, dialoguing with that thesaurus, we are providing all the necessary terminological context for the model. With everything in hand, the initial context from the paper, all the terminological variation that we may face, and the prompts, we then can do the linguistic inference using the LLM. We extract that structure, and then we send that to a component that allows ourselves to build a table, right, as a final output, desirable output. So the core message here is that first, one needs really to take care of engineering robust components that addresses this ability to first focus on the sections which are relevant, extracting the content, representing tables and text with the required engineering that needs to be established so that the information gets into the model in a way that the model can interpret. Now, if we look on how to do that within a specific agent infrastructure, and Lunar is such an agent infrastructure specialized in analytical use cases, we can see that we have here a panel where we have a set of components that we can reuse, right? Set of analytical components that we can reuse. And by dragging and drop these components within the main agent construction interface, we can speed up the construction of the agents. So instead of having to try to find the specific robust PDF extraction component or the table linearization, these are prefabricated components, analytical components that can be reused in other contexts. And of course, one specialized specific prompt types, specific elements of this extraction But this allows us to speed up significantly the agent construction process. So that's what infrastructures, agent-based infrastructures allows ones to do. And in this case, it's an infrastructure which it has this interface, which is a no code, low code interface that reduces the barriers for domain experts to directly build agents. So this gives an example of a simple agent and what are the mechanisms which are required for a literature review type of agent to operate in a safe and controlled manner, right? So the key element here is to reflect in the workflow of the analytical agent this controlled analytical decomposition and just reviewing that, right? So selecting the best content extractor for the target file type, building up an appropriate representation for tabular content, not assuming that the model is going to interpret an extracted table for a model that's particularly built towards sentence structures, interpreting the document layout and selecting the target sections, defining a controlled context for the specialized terminology or vocabulary, and determining the best external component to enrich this model's vocabulary. And finally, normalizing everything into the target output, in this case, a tabular output. Now, the value, as we spoke before, is that once this built, this represents a major efficiency gain. So you have that spatialized agent that you can reuse in future contexts, right? So you have new literature emerging, you can just reuse that agent, and this allows for that scalable evidence extraction. Thank you for your attention.